Hi everyone, and welcome to 4.1 day 2. We are continuing to solve quadratic equations. So just want to remind you a couple things that we talked about last time. When we're solving quadratics, we're finding the value of x when y is equal to 0, or where the parabola intersects the x-axis. We talked about the acronym ROCKS last time, which stood for several different ways of describing our solutions. One is roots, another is zeros or x-intercepts, or finally just solutions. And so those terms will be interchangeable whenever we're talking about the solutions or solving quadratic equations. And again, ROCK stands for roots, zeros, x-intercepts, and solutions. Let's go ahead and talk about types of solutions for a minute. If we have two real solutions, that means that our graph of our parabola crosses the x-axis in two places. If we have one real solution, it means that it just comes and kisses or touches the x-axis, and so it doesn't have two solutions, it only has one solution. And then finally, if it has no solutions, then that means that it never crosses the x-axis. Now, I need to emphasize that this is no real solutions. We will talk about something next time called imaginary solutions. So let's just go ahead and make a note that if there are no real solutions, then that means that there are two imaginary solutions. And we'll cover this in 4.2, our next lesson. So the first type of solving that I want to show you today is solving by graphing. And so we have a quadratic equation here. It is in standard form, in the form of ax squared plus bx plus c is equal to 0 because we are solving, so y is equal to 0. And so I can identify my a term, b term, and c term. And we need to remember back to chapter 3 to remember how to find our axis of symmetry and our vertex and our y-intercept. The y-intercept is super easy. It's always going to be this c value in our standard form. So this is the y-intercept. And so it looks like it intersects the y-axis at -3. So that would be a x value of 0 and a y value of -3. Our axis of symmetry, if we have standard form of our equation, remember that that's a line at x equals something, and that something is -b divided by 2 times a. So for our example, we have negative and then b is 2 divided by 2 times a, and a is 1. So that means that at x equals -1 is our axis of symmetry. Once we know the axis of symmetry, we can calculate the vertex. Remember that you just plug into the equation and solve for y. So I'm going to say that y is equal to, I want to plug in a value of -1 for x and square it, plus 2 times -1, and then minus 3. So my y value is equal to -4 when my x value is -1. I've calculated that now. So I've got some points that I can plot on my graph. Let's go ahead and indicate those, x's and y's. I have 0 and -3 that I can plot, and I have -1 and -4, and I also know where my axis of symmetry is. The axis of symmetry is at x equals -1. So let's identify that as our axis of symmetry. I can plot my vertex at -1, -4, and I can plot my y-intercept at 0, -3. If I have that point, I can also mirror it over here to get another point, but I still need to find my x-intercepts because that is what is going to define my roots or my solutions or my zeros. So let's go ahead and jump over to Desmos and get some more points on our graph. I'm here at Desmos.com, and this is the regular one, the graphing calculator, and I want to go ahead and put in my equation in standard form. Instead of putting a 0, I'm going to put y equals and then say what my standard form is. So it was x squared and then plus 2x and minus 3. All right, so I can get, let's see, there's the points I already calculated, my vertex and my y-intercept, and now I can see that my x-intercepts are at -3 and also at 1, and of course the y values are 0. Now let me show you what happens if you don't put in a y, if you put in a 0. So if you put in a 0, it thinks that you are only wanting to solve and not really graph the parabola, and so it's only going to give you lines where the solutions are. So don't do that. Go ahead and put in y equals and then the standard form of your equation so that you can actually see the full parabola. So the points I'm interested here is -3, 0, and 1, 0. Let's jump back over to our notes and take a look. Okay, so from Desmos, I can get more points. We saw that we had a point at 0 for a y value and an x value of 1. And then we also had another 0 for a y value when we had an x value of -3. Those are our roots or our x-intercepts. So we can go ahead and plot those and get a rough sketch of what the graph is going to look like. And at the same time, we can note those 2 points as being the points where our roots or our solutions occur. So 1, 0 and -3, 0. Or if you wanted to write them in x equals form, it would be x equals 1 and x equals -3. So those are the solutions for this particular graph in this problem.